Welcome back, everyone, to the Deep Dive, the Data Zen AI Podcast. We're here to help you make sense of the tech landscape. And today, wow, we've got a really fundamental question. It's something pretty much everyone building with AI is grappling with. Where should your large language model actually live?
Yeah, it's a huge decision. And honestly, it goes way beyond just, technical preference. This choice, it really impacts everything. Your costs, your compliance headaches, how fast your apps feel, and critically, how quickly you can get something out the door.
Right, the GTM, the go-to-market speed, that's often, the big driver for businesses, isn't it? We'll definitely keep that in mind as we go through this. So we've dug through a whole stack of material comparing the two main approaches, using cloud-based LLMs, it's often called LLM inference as a service, versus running the models yourself, locally, the self-hosted way.
And our goal here really is to give you a solid framework, something practical. We want to help you figure out how to balance those key things. The cost, keeping your data private, getting the performance you need, and importantly, what your team can realistically handle, technically.
Okay, perfect. But before we dive into where they live, maybe a super quick refresher, just so we're all on the same page. What exactly is a large language model, an LLM?
Sure. So at its heart, an LLM is, well, it's a very complex AI. Think of a massive digital brain, a huge neural network. It's been trained on just unbelievable amounts of text and code, mountains of data. And that training lets it get really good at understanding and generating human language.
So tasks like figuring out what someone means when they type a question, that's natural language processing.
Exactly, NLP. Or the flip side, natural language generation, NLG. That's where it actually writes things, code, emails, marketing copy, you name it.
And we're talking about the big names everyone hears about, right? Models like GPT-4, Claude 3 from Anthropic, Google's Gemini, those closed commercial ones.
Yep, those are definitely part of the picture. But also, and this is really important, we're talking about the open source models too. Things like Llama, Mistral, DeepSeek.
Yeah.
They're getting incredibly powerful.
Okay, so when we argue about where the LLM lives, what part of the process are we talking about? It's not the training, right? Because that's crazy expensive.
No, exactly. Training these things costs millions, sometimes tens of millions. We're focusing purely on the inference stage. That's the moment you actually use the model. You send it a prompt, like a question or an instruction, and it computes the answer, generates the response. The big question is, are you going to pay someone else, a cloud provider, to do that computation for you? Or are you going to build the setup to do it yourself? That's the fundamental choice.
Got it. Okay, let's break down these two main ways of doing things. Two different philosophies, really. It's like renting versus owning your AI power. Hashtag 1.1 cloud-based LLMs. LLM inference as a service.
So, starting with the cloud model, LMS, as we call it, this is all about simplicity and speed to get started. These models, the GPTs, the Claudes, they're proprietary. You don't own the model itself. You don't see the internal workings. They're fully hosted, fully managed by vendors like OpenAI, AWS, Google Cloud, Anthropic.
And getting access sounds incredibly simple. No need for your own fancy servers or anything.
No, not at all. That's the beauty of it. You access all that power through what's called an API, basically, a web address you send requests to. Usually it's just a standard HTTP request. You include your secret API key, and that's it.
Wow. So zero hardware setup on my end, just integrate that key into my application code, and I'm live.
Pretty much. Often within hours, seriously. That's why it's so strong for that GTM metric we mentioned. And all the back-end headaches, forget about them. The provider handles everything. The complex maintenance, making sure it can handle sudden traffic spikes, updating the models, patching security holes, optimizing performance. It's all managed for you.
That sounds almost too good to be true, especially for, say, a startup or a team that needs to move fast. Like if OpenAI drops a new, better GPT model tomorrow, I just change a line in my code, right? I don't need to buy new GPUs or mess with drivers.
Exactly. No hardware nightmares. It makes this approach really, really suitable for teams maybe without deep specialized ML infrastructure knowledge or, teams without a massive upfront budget for servers. It just removes that whole layer of complexity.
But there's always a but, isn't there?
Yeah.
Does that simplicity have a hidden cost? Like, am I getting locked into that one provider if I rely entirely on their API?
You hit the nail on the head. That is absolutely the strategic trade-off. Vendor lock-in is a real risk. Your time to market is super fast, yes. But if your whole application becomes dependent on, say, a unique feature of GPT-4's API or a specific way Anthropic handles something, what happens if they suddenly jack up their prices or change their terms? Switching providers can become a massive, expensive rewrite job. So you're trading that infrastructure control for speed and convenience, but also for dependency. Hashtag tag 1.2 local self-hosted LLMs.
Okay, let's flip the coin. The ownership path.
Yeah.
Running LLMs locally or self-hosted, this is where you take the reins, right? Full control.
That's the idea. Here you're actually downloading the model software itself. And almost always these are the open source models, Llama, Mistral, Phi-3, things like that. You run it on your own hardware. That could be servers in your own data center, what we call on-premise, or maybe dedicated machines you rent in a private cloud setup. The key is it's your environment. Fully self-contained, it can even run completely offline, which is crucial for air-gapped systems in, say, defense or sensitive research.
It's amazing how much this has changed, isn't it? A few years ago, running a decent LLM locally felt like something only Google or Meta could pull off.
Totally. But the open source community and the tools around it have exploded. It's genuinely democratized self-hosting now. Tools like Ollama, for instance, it's become super popular. It basically acts as a simple engine to run these models on your regular computer, Linux, Mac, Windows. Makes it way easier to just download a model and start playing with it.
And you mentioned Open Web UI. That gives it the nice chat interface.
Yeah, OpenWeb UI is great because it gives users that familiar, polished feel, like using ChatGPT online, but it talks directly to your local Ollama setup. So you get the nice user experience, but with the security and control of knowing the model and your data are right there on your machine or your private server.
But what if I'm a developer? I want my application to talk to this local model, not just use a chat window.
Yeah.
I'd probably want something like the OpenAI API standard, right? So I don't have to rewrite everything.
Exactly. And that's where tools like OpenLLM come in. They're like a bridge. OpenLLM lets you take basically any open source model, your Llama, your Mistral, and wrap it up so it presents itself to your internal network as an OpenAI compatible API. So your application code, it thinks it's talking to GPT-4 via a standard API call, but really it's talking to your privately controlled self-hosted model. It's incredibly powerful. You get the control and you leverage the existing ecosystem built around those commercial APIs.
Okay, so the difference in requirements is huge. Cloud is about convenience, speed, low initial effort. Self-hosting, though, that's for organizations that either have the deep tech skills, the MLOps teams, the engineers who understand GPUs, or are willing to invest heavily to build that capability. And they need the budget for the hardware, too. All right, this is where it gets really interesting, I think, the money and the speed. Let's really unpack the trade-offs between paying as you go versus that big upfront investment.
Let's start with cloud again. The cost initially looks very appealing. It's an operational expense, OpEx. You pay for what you use. Usually it's per token, a tiny fraction of a cent for each word or part of a word processed. Or maybe a monthly subscription tier. The barrier to just trying it out is super low. Great for experiments, proofs of concept.
Yeah, we saw those figures, like GPT-4 costing maybe 3 to 6 cents per 1,000 tokens. Sounds cheap. But the sources suggest this can become, well, not so cheap pretty quickly.
Oh, it absolutely can. And here's the key thing to understand. That per token cost can explode depending on how you use the model. Think about complex applications, maybe something using retrieval augmented generation, or RAGI, where you're feeding the model large documents to give it context for its answer, or applications using really long context windows, keeping track of long conversations. You pay for every single token you send in and every token the model sends out.
Whoa, okay. So if my app needs to analyze, say, a 50-page legal document every time a user asks a question, even if the final answer is short, I'm paying for all those input tokens from the document.
Precisely. That context window cost is the silent killer for high-volume RAG or long conversation apps. We're talking recurring monthly bills that can easily climb into the tens of thousands of dollars. For really heavy users, it can even cross into 6 figures per month. So the sweet spot for cloud costs. It's really for R&D, maybe smaller apps, or situations where your usage is really unpredictable or generally low.
Okay, so self-hosting flips that. You bite the bullet up front with a big capital expenditure, CapEx. How big are we talking?
It's significant. The main driver is the hardware, specifically high-performance GPUs. They aren't cheap. Plus, servers, cooling, power, and crucially, the salaries of the specialized people you need to set it all up and run it. Training models like GPT-3 cost tens of millions, but even for inference, just running a good open source model, a medium-sized company might easily spend, say, hundreds of thousands of dollars just on the initial hardware and setup.
Ouch. That sounds like it rules out a lot of businesses right there.
It can seem that way, but here's the payoff. If you have consistent, high-volume needs, self-hosting can become much cheaper over the long run. The sources suggest a rough tipping point might be somewhere around maybe 100 to 200 million tokens processed per month. Depends on your labor costs, electricity, the model size, of course. But if you're consistently operating above that level, paying that big chunk up front means you escape the endless treadmill of API fees. Over 3, 4, 5 years, self-hosting can save you a lot of money compared to paying per token indefinitely. Hashtag tag 2.2 performance and latency requirements.
Let's talk speed, latency. For some apps, a delay is just
Yeah.
unacceptable, right? Like live translation or maybe an AI coding assistant suggesting code as I type. I need it now.
Absolutely. And this is where physics gives local LLMs a natural edge. Because the computation is happening right there on your local machine or your nearby server, you cut out the network travel time. You eliminate the lag of sending your request over the internet to, say, Virginia, waiting for the cloud server to process it, and then waiting for the answer to travel all the way back. With local setups, you can often get response times down under 100 milliseconds. Very snappy.
That network time makes a huge difference. There was a really striking example in the sources about code generation, wasn't there?
Yeah, the DistBlue cover example. They use local AI reinforcement learning to automatically write unit tests for Java code. Running locally, it took them just 1.5 seconds per test. But when they tried to do something similar using cloud LLMs, the round-trip network latency and the way the results stream back meant it took 20 to 40 seconds per test. For something you need to do quickly and repeatedly, that difference is massive. It changes the whole user experience.
Okay, so cloud LLMs inherently have that network latency, usually what, 100 to 500 milliseconds, maybe more, depending on where you are. Does that mean cloud is just slower?
Not necessarily in terms of raw compute power or how consistently it performs. Remember, these cloud providers have poured billions into optimizing their infrastructure. They use huge clusters of the latest GPUs, sophisticated load balancing, dynamic resource allocation. They can deliver very high speed and consistent performance at a massive scale. It's actually really hard, maybe impossible, for most companies to replicate that level of optimized performance locally without a dedicated expert MLOps team. So the trade-off isn't just raw speed versus latency. It's also about the consistency and reliability of that performance, managed by experts. Hashtag 2.3 scalability and availability.
Okay, scalability. This feels like a big one. What happens when demand suddenly spikes? Like an online retailer during Black Friday, suddenly getting hit with thousands of requests per minute. How do the two approaches handle that?
This is where the cloud really shines. Think of it like the electric grid versus your own backup generator. Cloud LLMs offer practically unlimited automatic scaling. It's elastic. If your traffic suddenly jumps 100x, the cloud provider system automatically spins up more resources almost instantly to handle the load. You just pay for the increased usage.
And that scaling comes with reliability built in.
Exactly. Cloud providers offer service-level agreements, SLAs, often guaranteeing 99.9% uptime or even higher. They achieve this through massive redundancy, automatic failover systems running in multiple geographic locations. You're paying a premium for that peace of mind.
So local LLMs are the backup generator in this analogy. Powerful, but limited.
Pretty much. Your self-hosted setup is limited by the hardware you currently own and have installed. If you suddenly need more capacity than your GPUs can handle, you're stuck. Scaling up requires physically buying more hardware, installing it, configuring it, setting up load balancing. It's a slow, manual, expensive process. It really limits your agility to respond to sudden demand spikes. And availability is more fragile, too. If one of your servers fails, you are responsible for the redundancy and failover. The risk of downtime is generally higher unless you invest heavily in building that resilience yourself.
So the bottom line seems to be, if you absolutely need guaranteed instant scalability for unpredictable demand, cloud is almost unavoidable. But if your workload is pretty stable, predictable, and mostly internal, local can work, assuming you've bought enough hardware upfront to handle your expected peak. Okay, let's move beyond just speed and money. This next part is about control. How much power do you need over the model itself, and crucially, over your data? Hashtag tag 3.1 data sovereignty and regulatory compliance.
Yeah, this is often the deal breaker, especially for certain industries. Local, self-hosted LLMs give you absolute control over your data, maximum privacy. If you're dealing with really sensitive stuff, personal information, PII, financial records, patient health data, PHI, that falls under regulations like HIPAA. Running the model locally means that data never has to leave your secure, controlled environment.
So for things like GDPR in Europe, where data residency is a big deal, or any industry with super strict compliance rules, self-hosting makes that compliance much more straightforward.
Definitely. It's generally the preferred route because it drastically reduces the attack surface. You're not sending your sensitive data out over the internet to a third party. You maintain full control, full auditability over your security. With cloud LLMs, you have to send the data to their servers. Now, the major providers have excellent security, tons of compliance certifications, strong encryption, but you are still placing trust in them. You're operating under a shared responsibility model for security and compliance, which can add complexity and burden, especially for finance, healthcare, or defense contractors.
It feels like the principle is, if that data is your crown jewels, you want to keep it as close as possible, right? Minimum external exposure.
That's exactly it. For many, the peace of mind of knowing their most critical data isn't crossing the public internet outweighs the convenience of a cloud API. Hashtag 3.2 customization and flexibility.
What about making the model smarter for your specific needs? Like if I'm a law firm using really specific legal jargon, or a hospital with unique medical terms, a general model like GPT-4 might not understand all the nuances, right?
Precisely. And this is where local, typically open source models give you much deeper customization options. Because you have the model, you can fine-tune it. That means you take the base open source model and continue training it just a little bit on your own proprietary data, your legal documents, your internal knowledge base, your medical research papers. This lets you bake your specific domain knowledge directly into the model. You can teach it your jargon, align it with your company style, implement very specific safety roles, and really tailor it to your exact workflow.
And we talked about the cost of this earlier. Fine-tuning locally seems way cheaper in the long run than trying to achieve the same specialization just by writing really long, complicated prompts for a cloud model.
Huge difference, yeah. With cloud models, your main customization tool is prompt engineering. But to get specialized results, you might need to send thousands of words of context with every single request. And since cloud vendors charge per token, that gets incredibly expensive very fast. It's like paying a toll every time you ask a question. Fine-tuning your own open source model locally means the specialized knowledge is in the model's weights. You can then use much shorter, simpler prompts, which means faster responses, and you start paying that perpetual context tax on every API call.
So cloud offers customization, but it's kind of predefined within the vendor's limits. Self-hosting gives you the keys to the kingdom, letting you truly mold the AI to your specific world. Hashtag 3.3 technical expertise and environmental impact.
But owning the kingdom comes with responsibilities. We have to be really clear about the expertise needed. Self-hosting isn't easy. It demands serious technical chops in MLOps, machine learning operations, and infrastructure management.
What does that mean in practice? Like, what kind of hardware are we talking about and who manages it?
Well, the hardware needs vary wildly. A smaller 7 billion parameter model. Maybe you can get away with a good gaming PC GPU with 8 GB or 16 GB of video RAM. But if you want to run one of the big, powerful 70 billion parameter models, you're likely looking at professional server-grade GPUs, things like NVIDIA's A100s or H100s with 40 GB, 80 GB, or even more VRAM per card. And you might need several of them. That's serious hardware. And then you need people who know how to actually make these things work reliably. They need to handle complex driver installations, optimize performance, maybe use clever tricks to make the models fit into less memory.
Let's talk about one of those tricks, quantization. It sounds technical, but it seems really important for making self-hosting more practical.
Oh, quantization is key. It's a huge enabler. Basically, it's a technique to shrink the model down. Models normally store their internal knowledge using very precise numbers. Technical term is 32-bit floating point or FP32. Quantization reduces that precision, often down to 8-bit integers, int8, or sometimes even less, like 4-bit. Think of it like using slightly less precise measurements, but it still gets the job done pretty well for most tasks.
The benefit of using less precise numbers.
It drastically reduces the amount of memory the model needs. So a giant model that might have needed a $100,000 server with multiple top-end professional GPUs might suddenly become runnable, maybe slightly less accurately, but still very useful, on hardware that costs a fraction of that. Perhaps even high-end consumer GPUs. Quantization is really what puts powerful self-hosted AI within reach for more organizations. It bridges that gap.
But even with quantization, it's not just plug and play. You still need people who understand this stuff, who can troubleshoot when the GPU drivers inevitably cause problems. We've all been there.
Exactly. That human expertise is the often underestimated cost. You need people who can navigate that complexity. And one last point here, maybe a bit sobering. The environmental impact. While running inference is much less energy-intensive than training, building and powering all the specialized hardware needed for widespread self-hosting still has a carbon footprint. Training just one big model was estimated to emit hundreds of tons of CO2. It's something to keep in mind.
So we've laid out the pros and cons of cloud versus local, but the sources seem really clear that in the real world, it's rarely a simple either-or choice. Most companies are actually mixing and matching, aren't they?
That's absolutely right. It's very uncommon for a large organization to go purely one way or the other. Their needs are too diverse. They might need the massive scale of the cloud for their public website chatbot, but demand absolute secrecy for analyzing internal financial data. So they blend the approaches. Hashtag TagTech 4.1 case studies in cloud LLM adoption.
Okay, let's look at why some companies deliberately choose the cloud path, even when dealing with complex areas.
Cloud really wins when speed, scaling, or leveraging a vendor's specialized pre-built expertise is the top priority. Take Mance, that Austrian legal publisher mentioned in the sources. They needed a sophisticated system to recommend relevant legal documents. They specifically chose DeepSet Cloud.
Why didn't they just build it themselves using an open source model?
Because they needed expert-level German language understanding specifically tuned for complex Austrian legal text. Building that expertise internally, hiring NLP PhDs, curating massive German legal datasets, fine-tuning models would have taken ages and cost a fortune. By using DeepSet Cloud, they essentially bought that niche expertise off the shelf. They prioritized speed and specialized capability over building it all from scratch. It was a strategic outsourcing decision.
And we see similar logic even in super-regulated fields like healthcare and finance.
We do. Look at Cognizant working with Google Cloud's Vertex AI in healthcare. They're using it to streamline back-office stuff, processing appeals, managing patient communications. They're leveraging Google's existing platform stability, their HIPAA compliance assurances, and their enterprise tools. For that kind of operational efficiency task using non-clinical data, the reliability and features of the cloud platform outweighed the need for absolute on-premise control.
And banking, traditionally very cautious about the cloud.
Even they're shifting. The example of Allied Banking Corporation moving core systems to Finastra's cloud solution shows that. They're recognizing that modern cloud platforms can offer the security and regulatory compliance needed, often more robustly than they could build themselves, while also providing cost savings and agility. So if the compliance boxes can be ticked, the cloud's advantages are very tempting. Hashtag TechTech 4.2, the blended approach, hybrid.
Okay, so cloud makes sense for specific strategic reasons, but the research really points toward this hybrid model as the dominant strategy now for Gen AI. Most companies using a mix.
Yeah, it's become the standard mature approach. Why? Because it lets organizations get the best of both worlds. You strategically balance the trade-offs.
So how does that work in practice? How does a company decide which tasks go to the cloud API, like OpenAI, and which tasks run on their internal, maybe Llama-based system?
The dividing line is almost always data sensitivity and the need for customization versus the need for scale and generality. Typically, organizations use the commercial cloud APIs, your GPT-4s, your Claudes, for things that face the public, need rapid prototyping, require the absolute latest, most general knowledge, or need to handle huge, unpredictable traffic spikes. Think customer service chatbots, general content generation, summarizing public web pages.
And the internal self-hosted models handle.
They get the sensitive stuff. The open source models running locally, whether that's truly on-premise servers or maybe dedicated virtual machines in a secure cloud environment, they handle internal tools, processing confidential company data, R&D using proprietary information, and any task that requires that deep custom fine-tuning we talked about. That's where the company's unique secret sauce lives, protected internally.
So it's like you rent the general purpose, scalable AI from the big providers, but you own and carefully cultivate this specialized AI that understands your core business and handles your sensitive data.
Exactly. It plays to the strengths of each approach. Let the vendor manage the massive scale and complexity for the public-facing parts, while you maintain absolute control, security, and customization for your critical internal operations and intellectual property. It's a smart way to manage risk and capability.
Okay, this has been a lot to cover, so let's try to boil it down. What does all this mean for you, the listener, trying to make this choice? We've pulled together the key questions you really need to ask internally to figure out the right path. It's all about matching the deployment strategy to what your organization actually needs and can handle. Hashtag Tag 5.1 key questions to determine deployment.
Right. Start by asking yourself these 4 crucial questions. They really force you to be honest about your capabilities and priorities.
Number 1, do you actually have the necessary in-house expertise? The MLO skills, the infrastructure know-how?
And to be really honest here, If you don't have a team comfortable with managing GPUs, dealing with Linux dependencies, understanding virtualization, optimizing models with things like quantization, then the cloud is almost certainly the better, safer choice. LLM Montes takes that entire technical headache away. Your existing IT folks can focus on integrating the API, not becoming GPU cluster admins overnight. Self-hosting demands a specific, often new, and expensive skill set.
Okay, question 2. What's your budget realistically look like, both upfront and ongoing? And what are your usage patterns?
Yeah, look at the numbers. Is your usage going to be low, maybe sporadic, unpredictable, or are you just experimenting? Then the cloud's pay-as-you-go model makes sense. Low initial cost, low risk. But if you foresee really consistent high-volume usage hitting those hundreds of millions of tokens per month, then doing the math on the upfront capex for self-hosting versus years of API fees becomes critical. Self-hosting can save significant money long-term if the volume is there.
Third, and this is huge, how sensitive is your data? What are the regulatory requirements?
Non-negotiable for many. If you're handling PII, PHI, secret R&D data, military info, or anything governed by strict rules like GDPR or EPA, and especially if data must stay within a specific country, then local on-premise deployment offers the clearest path to control and compliance. Choosing cloud means you're accepting that shared responsibility model, you're trusting the vendor's security, and you need to be comfortable with your data leaving your direct control, even if it's encrypted.
And finally, question 4. How fast do you need this thing up and running? What's your required time to market, GTM?
Speed kills, or in this case, enables. If you need a minimum viable product, an MVP, out the door next month, cloud APIs are basically your only option. It's fast, API key, some code, boom. Self-hosting involves a significant lead time just for the infrastructure phase, ordering hardware, waiting for delivery, physical installation, network setup, software configuration. That's weeks or even months before you can even start building the actual application on top of it. Hashtag tagged 5.2, summary of optimal choices.
Okay, so let's try to summarize this into a quick decision guide for you.
All right. Choose cloud-based LLMs if city. Speed is your absolute top priority. If you need that massive elastic scalability for unpredictable traffic, if you want to minimize upfront costs and avoid managing complex infrastructure, and if your data isn't subject to the absolute strictest privacy or residency rules, cloud is about agility and convenience. And choose local self-hosted LLMs if data privacy and control are paramount. If you're in a heavily regulated industry like finance or healthcare, if you need deep customization via fine-tuning on your own data, or if your usage is consistently so high that the long-term cost savings of owning the infrastructure outweigh the initial investment and ongoing maintenance effort. This path is about sovereignty and tailored performance.
And, as we saw, for many larger organizations, the answer isn't one or the other. It's that hybrid strategy.
Yeah.
Use the cloud for scalable, general tasks, and keep the specialized, sensitive AI running securely in-house. Best of both worlds, potentially. Hashtag tag outro.
Wow. Okay, looking back at all the material, it's really clear this decision, cloud versus local for your LLM, isn't just about picking the best tech. It's fundamentally a strategic decision. It's about aligning your infrastructure with your business priorities. Cost tolerance, risk appetite around data, your team's actual capabilities. Knowing yourself seems more important than just chasing the latest model. Couldn't agree more. It really sets the direction for your AI architecture. But here's a final thought, maybe a bit provocative. Regardless of whether you go with the convenience of LLMs or the control of self-hosting, one thing is absolutely essential: MLOps expertise. You need people either on your team or that you bring in who understand how to reliably deploy, monitor, optimize, and secure these models in production. That skill set is non-negotiable for getting real long-term value out of any LLM, no matter where it physically runs. It's the human layer that makes the AI truly work.
That's a great point to end on. The people behind the tech are key. Well, thank you for joining us on this deep dive into LLM deployment. We hope this framework helps you make the right choices.
Yeah, hope it was useful. If you enjoyed this discussion, please do subscribe to the podcast. We're on Spotify, Apple Podcasts, all the usual places.
And we genuinely love hearing from you. If you have feedback, ideas for future topics, or just want to connect with the Data Zen community, please check out our website, datazen.top. You'll find more resources, info on meetups, and other insights there.
Thanks again for listening, and we'll catch you on the next deep dive.